Hello everyone. Today I'm going to present my project, an Arduino-based solar tracker with dust detection and vibration cleaning system. While searching for a space-related project idea, I asked ChatGPT for suggestions. Out of all the options, I chose this one because it reflects actual technologies used in space missions while still being useful in everyday life. For example, it could be used on house rooftops to boost solar efficiency by following the sun and cleaning itself. The solar tracker uses dual-axis rotation based on light intensity from four LER sensors. It's designed to automatically adjust the angle of the solar panel to capture the most sunlight throughout the day. Additionally, there's a dust detection system. When high dust levels are detected on the panel, a vibration motor activates to shake off the dust, while a buzzer alerts the user. Here, here's a quick overview of the components used in this project. The Arduino Uno serves as the brain of the system. Four LDR sensors track the sunlight intensity in different directions. Several motors control the solar panel's rotation. A dust sensor detects when dust has accumulated, triggering the cleaning system. An LCD display shows dust levels and panel positioning, and a buzzer sounds when cleaning is necessary. To start included the necessary libraries: servo for the motor, wire for I2C communication, and liquid crystal I2C for the LCD display. Then I initialize the LCD using the common I2C address 0x27 with 16 columns and 2 rows. Next, I declare all the input and output pins. These include the light sensors for tracking sunlight, a dust sensor, servo motor for movement, a vibration motor for cleaning, and LEDs to indicate the dust level. I also added a push button to manually trigger the cleaning mechanism. In the setup function, I attached the servo motor to set it to start at the center. I configured the pin modes, initialize the LED, and display a short welcome message. I also started serial communication so we can manually input dust values for testing. In the main loop, the system reads the value from both LDRs to determine which direction has more sunlight. It also checks the serial monitors for manual dust inputs, which is used if we don't want to rely on the sensor during testing. The dust value comes either from the sensor or from manual input. If a user types 0, the system uses the sensor. Otherwise, it uses the manually entered value. This flexibility helps with debugging and simulating different conditions. If there's a significant difference between the LDRs, the servo adjusts the panel position by a few degrees toward the brighter side. This movement, this movement keeps the panel aligned with the sun throughout the day. The LCD displays the dust value on the top row. On the bottom row, it shows whether the panel is moving left, right, or it's balanced, along with the current servo angle. There are three LEDs that act like a traffic light to show the dust level. Green means low, yellow is moderate, and red indicates a high level of dust, which might require cleaning. When the dust level is high or when the button is pressed, the vibration motor and buzzer turns on. This simulates the cleaning mechanism activating to shake off the dust from the panel. Finally, the serial monitor displays live sensor data for dust and LDR readings. This helps us to observe how the system behaves in real time and is useful for debugging and demonstrating the system's response.
Hello everyone, in this video, I will walk you through the circuit design and demonstrations of a smart Arduino-based solar tracking system. It's not just a tracker, it detects dust buildup on the panel and automatically triggers a vibration-based cleaning mechanism, with a buzzer alert LED to indicate dust state and manual cleaning options as well. Let's begin with the circuit. Here's how the circuit is laid out and what each component does. Start with Arduino Uno. The Arduino Uno is the main controller managing input from sensor and controlling the output like the servo motor or display. Next is LDR. This is LDR. Two of these. Two LDR are connected to analog pin A0 and A1 using 10K resistor. This measures light intensity from two directions around the panel. The values are used to determine the sun position in x-axis. This is x-axis, like this. Next is servo motor. This is the blue. Servo motors are connected to pin 9. Yeah. Rotate the panel horizontal, leading from the LDR. Next is dust sensor. Dust sensor is connected to analog pins A4. A4 is around this. And it detects dust concentrations on the panel surface. Higher value indicates more dust. Next is vibration motor. This the circle. Vibration motor connect to pin 6. This is pin 6 around this. A small vibration motor is connected to pin 6 when dust level are high. Arduino send a signal to this pin to activate the motor and clean the panel. Yes. Next is a buzzer. Buzzer is connected to pin 7 and give an audio alert when dust level is high. Next is 3 LEDs. Connect to pin 3, 4, and 5. This blue LED indicates normal operations. Yellow LED turn on when dust level is moderate, and red LED turn on when dust is too high. Next is LCD display. We use 16 multiplied to LCD with 12C module. It's connected using two wires. It shows the dust value and servo angle in real time. Next is a push button. Connect to pin 8. A button is connected to manually trigger cleaning even if that level is low or moderate, useful for demo or emergency cleaning. Now let's demonstrate how the system works in real time. Step 1. Power on. Connect the Arduino to a computer and run it. Wait a minute. The LCD shows solar track int. Then begin display dust level and angle X. Next is automatic solar tracking. Shine floodlight around the panel like this. It will move. The LDR detects change in light intensity. The Arduino compares left and right value. Based on this, it sends signal to X motor to rotate the panel toward the socket light source. Like this. If the light is strong, it will move left. Okay. Next is simulating dust. The LCD shows dust value like this. In this environment, the dust value is not changed. We will simulate in serial monitor like this. The threshold of high level is 800. If we press 900, it's above the threshold. It means the high level of dust. The LED LED is on. The buzzer sound vividly, and the vibration motor turn on to clean the panel. Next is moderate level. It's between 400 to 800. If we put 500, yes, the yellow LED is on, and buzzer and monitor is not work. And then if it's below 400, yes, the blue LED is on. Okay. If we want to measure the dust value by using dust sensor again, we type 0. Yes. Type 0, and then the monitor will show the value according to dust sensor. And next is manual cleaning. If we press the push button like this, yes, the vibration monitor is work. Even when the low dust or moderate dust level, the vibration motor turn on. This shows that the user can manual trigger cleaning at any time that we want. Okay, and this is a current just a prototype. In the real system, the dust sensor and vibration motor would be placed directly on the solar panel. The sensor would monitor dust level, and if the value go above the certain threshold, the vibration motor would activate to clean the surface. Once the dust level drops below the threshold, the motor automatically stops. And that's the end of our presentation. Thank you everyone. Bye bye.